And yeah, so I'm going to talk about what's new in Spark 4.2 and also what's coming in 4.3. 4.2 isn't officially released yet, but there's a preview version of it that was released. And we're doing the branch cut actually on Friday. I want to say, I'm looking at my calendar. So you can start playing with it today, but it's not like officially released all the way. So I'm going to talk about sort of like who I am, why you should listen to me, what UDFs are, especially for folks who maybe aren't coming from a super Spark heavy background, what's changed in Spark 4 specifically around UDFs, and how we can use this to squeeze more performance out of Spark. And also ideally, get some more rest. No one likes staying up all night debugging performance issues or out of memory exceptions. And then we're also going to talk about where this can all go wrong, because that's the reality. None of the stuff is perfect, and distributed systems are really, they're 300 computers wearing a trench coat, and the problem is when one of them falls over, if things go poorly, all of them fall over. Spark's intention is, of course, that almost any of them can fall over and it will just work, but that doesn't always work out. So yeah, I'm Holden. My pronouns are she or her. I'm working on open source Spark at Snowflake, and I'm a co-author of several books about Spark and other related topics. So I've been thinking about distributed systems for a very long time. And you can follow me on sort of the standard social media places. I do a lot of open source live streams working on Spark. I'm not doing really any until, I get my voice back. I drank a lot of tea right before this one. So taking a quick break, but I'll be back. And in that, it's a lot of just working on Spark and related tools. I'm also a dog mom. It's a lot easier than being like a human mom. So I look after Professor Timbit. We can see him here asleep in my bed with an IKEA shark behind him. And he is very, I would say, lucky. He doesn't know what computers are. He doesn't know what an out of memory exception is. He just knows, that life is pretty great, and sometimes it rains. So he has a pretty great life. And sort of in addition to like that, who I am professionally, I'm trans, queer, Canadian, although now a US citizen. So I'm Canadian American and part of the broader leather community. And I like to say this isn't overly related to distributed computing or machine learning, but for those of us who are building machine learning systems, it's really important that we look at everyone who's in the room with us. And if we see that everyone is maybe Berkeley class of 2024, then it's time to try and get some other voices in the room. And I think this is especially important because these machine learning systems, if we're not careful, we're just going to sort of launder the existing biases of the world. We're just going to make the things that are unfair happen faster. And I would like to see us not do that. I would like to see us make the world a little bit better. And I think we have an opportunity to do that because we're at an inflection point. So for people who aren't super familiar with user-defined functions, that's really just a way of saying everything that wasn't shipped as part of Spark itself. So if you write a function to compute the square root, or if you write a function to, split up word tokenization, or maybe not even words, maybe you're just trying to do tokenization for indexing, right? You've got, bigrams or trigrams or something like that. These things can all be user-defined functions. And these are different than the built-in functions because Spark generally doesn't really know what's happening with them. And currently, you can write them in Scala, Java, or Python, and Spark 4 added the ability to write them in SQL. Now, writing them in SQL is still kind of annoying because you're writing SQL. And a lot of the reason why people choose to write UDFs over, say, just writing more SQL is that expressing their logic is kind of hard in SQL. And so, yeah, why do people use UDFs? So fundamentally, it's easier to express their logic as a function than as just a large number of transformations stacked on top of each other. A large part of it this can be an excellent way of accessing libraries. So if you've got business logic that lives in a library, if you've got BLAS, right? If you've got really anything that isn't part of the standard SQL, UDFs and user-defined aggregate functions are sort of the de facto way to bring that to either your SQL or your data frame operations. Another one, even when it might be easy to write it inside of SQL, is maybe you've got pandas data frames and you're porting that logic into Spark. Spark recently, Spark 4-ish timeframe, added pandas on Spark, previously called koalas. I had a very earlier version of this called sparkling pandas. In all of these cases, you would tend to write things in such a way that you would be using functions. And yes, you could express them relatively easily with Spark native operations, but because you're porting sort of this existing code, you end up with a large number of relatively simple user-defined functions. Another one that's super important is just frankly, UDFs are, in my opinion, often a lot nicer to read. Nested if-else statements or conditional expressions in SQL are just kind of unpleasant to write and read. Network access and also performance. A lot of the challenges of user-defined functions are performance, but on the flip side, you can sometimes do really cool things, right? So like accessing specialized linear algebra libraries are going to be a lot more efficient than if you tried to express the same logic in SQL and then have a SQL engine execute it. And so let's talk about sort of why this is a challenge. The fundamental challenge is that the optimizers can't really see inside of them, with the exception of SQL UDFs. And this can be everything from like, there's no way to tell if UDF is expensive or simple. And so generally we kind of assume inside of Spark that a UDF is expensive, but maybe you're just adding, two numbers together and it might not actually be all that expensive. So optimizer rules are not really written very well for them. Also, because we can't see inside of them, we don't know what's happening. So we can't really reorder stuff around them in the way that we can with SQL operations. Often it can require shifting the data format. And so internally, Spark has Catalyst, and it's got its own internal representation. We've got Arrow for talking to Python. We also have other formats too. And then there is also, the shuffle format. And when we have to use UDFs, we have to convert it out of the internal representation into either the native Scala Java type or into the Python types, which can be much more expensive. And so this can obviously make things slow. Copying data, shifting data formats, but slow and historically error prone, not so much anymore. There's really great fidelity with Arrow and all of the Spark internal types. Sometimes there's a little bit of weirdness with date times, but that's just the joys of life. Other one is they're only available in the application they're registered in. This is a problem, especially something I encountered a lot at Netflix, where we would want to share sort of some core functionality between a whole bunch of different people, and no one wants to have to go and re-register all of the UDFs inside of every function. And then finally, they're also difficult to observe, right? So we don't know why they're running slowly. That black box sort of continues through to the observability part. And finally, I guess, the security becomes a lot more fun. And so if you're trying to do fine-grained rule-based access control on your data, because UDFs can sort of contain arbitrary things, it's really hard to say this UDF isn't trying to do anything evil. And so as such, executing arbitrary code sort of puts you in a place where you're like, I don't know what this person's trying to do. We really have to make sure that there's no data inside of this VM that they shouldn't have access to, right? And so that really makes security a bit more challenging. Right, so we're gonna dig a little bit more into the black boxes and push down. And here we've got a box of Timbits. My dog's name is Timbit. And here we can see we know this is a box of donuts, but we don't know what kind of donuts are inside, right? Although we can see the top of one donut sticking out. So we know that at least it's not all chocolate donuts. But for example, like this could be, right? Like, we've got a return type probably, I would say, of, it looks like honey glazed, but internally it could be all chocolate donuts. And then we would want to eat a different amount of donuts. stretching the analogy a little bit far. But and to that point, right, these black boxes break pushdowns, and these pushdowns are super important in Spark, right? And not just Spark, all engines. Data is often organized in ways where we only need to read little bits of it, right? This is super, super important because processing data is expensive. And if we don't have to read it, then we don't have to process it, right? And so if we have to read 100 terabytes of data because we've got this UDF in the middle and we don't know if it's safe to move a filter below that UDF, it's not great, right? And this is not ideal. And so these UDFs mean that we end up reading more data than we might necessarily have to or otherwise want to. And like, yeah, you can, of course, like it'll work. You can buy the compute for it. But that's going to get expensive. And also you can be pulling from things that aren't just S3, right? Like maybe your data source is some like super expensive source, like, you know, you wrote a custom data source and you're querying Anthropic for everything, right? And so then this just gets incredibly even more expensive. And so the more we can push things down, the more we can filter, the better it is, right? And the things that we can push down can be super, super advanced, right? Like filters are sort of the basic push down. But for example, if you were pushing down from Spark to Snowflake, you might want to push down like aggregates or something like that, because the Snowflake engine can execute all these aggregates really well. And then you have much less data transferred across the wire. So one partial solution to this is Spark is adding SQL UDFs. And this solves sort of the problem of like, cool, I want to make a function, I want to make it reusable, and I still want the optimizer to know what's going on though, and I want it to be able to like still do push downs. I want it to still be able to do, you know, all of its normal sort of things. And so this is cool. It does solve the problem, but you still don't get access to your libraries, and you're stuck with only doing the things that you can reasonably express in SQL. And frankly, that's not a lot of fun, right? But it is a partial solution. It gets us part of the way there. New in Spark 4, it's great. Right. Okay. So the data copying being expensive, right? How is that going to be solved? And here we can see actually, you know, doing things in the JVM is much less expensive than doing things in Python, because then we don't have as much data copying happening. And so PyArrow and vectorized UDFs are continuing to improve. So this graph, it looks really bad, but things are actually continuing to get better. It does have to, the data still has to be copied. To take advantage of this, you do have to use the Arrow UDFs. But importantly, you don't have to use the Pandas UDFs. And this is a really big thing, because with the Pandas UDFs, it was really easy to actually trigger a second or third data copy by accident. And so instead of working on Pandas data frames, you can directly work on the Arrows data frames. And so this is a big improvement. It makes it a lot easier to do really cool things. Here, you know, we've got Arrow. You can see I'm not a very good shot. Everything is down to the left. Hopefully Arrow is better at this than I am. Another thing is iterator to iterator transformations came for Arrow batches. This is super big. And this is maybe sort of like kind of a weird internal Spark thing, but this is really important for those out of memory exceptions, right? By being able to do these iterator to iterator transformations, Spark is more easily able to say like, oh, I'm running out of memory. I need to spill things to disk. And yes, spilling things to disk is slow, but it's a hell of a lot better than being woken up at 2 o'clock in the morning because this business critical pipeline was unable to run because it got an out of memory exception, right? And so this allows for spilling, and this is fantastic. Additionally, the amount of data being copied has been somewhat reduced through compression. During UDF execution. This was previously only used collecting results back on the driver. This is fantastic. You get that essentially for free. You don't have to change anything. Transform with state uses Arrow. Also, you essentially get it for free. Concurrent batch execution is something that you have to tune. And this is more for heavy IO workloads. So if you've got something, if you've got a UDF which is calling out to Anthropic, or you're making a call to VLLM, you're doing something where you're fundamentally just blocking on an external server rather than doing a lot of computation inside of Python. You can increase the concurrency here, and you can actually get really great performance improvements. So this is fantastic. Another thing that we're doing is we're making it easier to reuse UDFs. This is just a proposal. My guess is it's going to land in 4.3, not 4.2. Although the person who made the proposal is also in charge of the 4.2 release, so they might put it in. We'll see. But essentially, it allows us to put UDFs inside of catalogs, and at that point, we can share them between Spark sessions. It's not going to be perfect. I'm sure there's going to be a lot of like bumps in the road, but it lets us get around sort of some of the hacky workarounds that people have been using. So people like Netflix and stuff like that have had to be sort of shipping custom execution plugins where, when it starts up, it registers a whole bunch of UDFs. Not ideal, and this will make it a lot easier. And then also it'll make it so that you can like update these without having everyone to update their jobs. So this is fantastic too. And there are other partial solutions. And this is another attempt to sort of solve the problem of these UDF black boxes, although this is solving more the problem of the UDF black boxes that come from the pandas data frames, because it doesn't solve the library problem, because fundamentally NumPy is not available inside of SQL. So transpiling, essentially the idea here is a lot of people would rather write Python code or have written Python code, even if they're sort of ambivalent to writing Python or Spark code. But what we should do is when we encounter simple UDFs, we can convert those into internal Catalyst UDFs, which are SQL UDFs. And this is fantastic. It's been approved, and there is a proof of concept, and the tests even pass. And I'm actually, I've got a terminal window up right here where I'm working on it. When we've got a new node type where I was working on this a little bit to simplify how we do the resolution. It's probably not going to make it in for 4.2. As I was saying, the branch cut is Friday, but I think this is going to be there in 4.3 because people have agreed in principle to the plan. We just have to get everyone to agree about the specific implementation of the plan. And so here, to illustrate that point, we have a very broken Vespa and a bicycle. And I'm really optimistic that we'll put the Vespa back together and then we'll go zipping around our neighborhood and it'll be fantastic. Short of that, if we can't do that and we can't get everyone to agree, we've at least got enough agreement that we can get the little electric e-bike out and we can start zipping around the neighborhood on the little electric e-bike in 4.3. This one also will probably not require you to make that many changes to your code. There is talk of adding an annotation so that you can sort of tell the Spark compiler, it's not quite a compiler, but close enough, like, hey, I really want this UDF to be transpiled. And in that case, you could start adding that to things that you think are relatively simple and use that to figure out if it's working or not. But you don't have to. This is sort of hopefully a quality of life improvement that you're just going to get in upgrading to Spark 4.3. Now, notably, this does not in any way address Java. This is kind of hard. Transpiling Java code is really annoying. And for license reasons, actually, it's a little extra annoying. There are some libraries for looking at JVM bytecode, but they're not ASF v2 license compatible. And this means that integrating them into Spark is a challenge. We have to do it in very certain ways so that we can maintain the license and avoid accidentally picking up GPL components. I don't know if the Java version is going to happen. If you're the kind of person who's like, wow, I've always wanted to write a compiler, I have too much free time and my employer doesn't know what I'm doing, I would love to work with someone who has too much free time and wants to make this work for Java UDFs as well. And in that case, we would use raw bytecode. The Python one, it's a little bit simpler because we can get the AST because it's an interpreted language. And so it's much easier to transpile the Python AST rather than looking at JVM bytecode and trying to figure out what the hell people were trying to do. And to be clear, right, yeah, there is a branch and you can play with it today. But if you do, you should expect to break down on the side of the highway. And here we have my motorcycle broken down on the side of the highway. And right now it is also broken. In fact, not on the side of the highway. It's broken in front of my house with a nail in the tire. And the clutch is also a little wonky again. And yeah, so this is something that's coming in 4.3, but if you try and use it too early, you will probably run into problems. And so don't do this just yet. Right. Okay. And to drive that point home, if you do, everything will catch on fire. Okay. So safety third. And this is sort of a very important point. It's really important that we get this right, especially because the failure case of incorrect transpilation isn't just your code doesn't work, it's that it looks like it's working, but it returns incorrect results. So the plan here is to use hypothesis testing. It's a lovely, lovely library in Python, very similar to Haskell library, similar to ScalaCheck in the Scala land, where we can sort of define invariants about the code, and then we can verify that they're true. And this is nice because we do have sort of this default implementation that we're trying to match, and we can essentially say, hey, turning on transpiling, the results should be the same, except for these edge cases, which we accept are going to behave differently. And so there's a bunch of things to do. I think a really interesting thing here sort of could be with the velox stuff, where we might want to transpile directly to velox IR or something like that, instead of always necessarily going through Catalyst IR. But that's a very much like a vNext feature. Profiling, I mentioned it's really hard to know what's going on with SQL UDFs. With Python UDFs. There's a fantastic Python UDF profiling tool now that's built into Spark. The blog post about it is on the Databricks website, but this is an open source Spark. You don't have to be a Databricks customer to use it. I'm not a Databricks customer.
Holden, before we keep going, I want to also just flag for people, if you have questions, jot them in the chat right now or in the Q&A, because we're right away moving into a Q&A.
Yeah, and so final points. There is also a proposal. This one, I don't think it's coming in 4.3. This is more 4.4, where we decouple the UDF execution from the main Spark executor. And this will let us support more languages with higher overhead. And I think it'll also let us provide fine-grained rule-based access control in situations where that's needed, but it does come out at an additional overhead. So this will probably be an opt-in feature, depending on what people need. Also, I've written a bunch of books, as I mentioned, and there's a new version of High Performance Spark most likely coming out in June. I say most likely because my editor sent me a bunch of emails this morning telling me that I have to do a bunch of stuff that I'm going to try and do. But as I mentioned, I'm getting over a cold, so I'm going to do my best. It should be out in June. Regardless, you can pre-order several copies today with your corporate credit card. And I also have a kids book that will hopefully be coming out around the same time. If you've ever said to yourself, wow, I hate children, and I want them to know what an out-of-memory exception is, go to distributedcomputing4kids.com. And this is also suitable for executives who may be asking you to do things that just don't work. And so you can go ahead and sign up to be notified when that's available. And that's it. Let's jump over to Q&A.
Parents out there, don't miss on this opportunity to subject your children to this.
Yeah. Also, if you do like children and you have patience and you're willing to explain things to them, I think this is a great book to help them understand what you're working on. I think it's great. We sort of explain distributed system concepts through a bunch of garden gnomes hanging out together, working with two children to split up a problem and sort of solve it collaboratively, and showing how this is similar to how computers work together to solve problems.
That's brilliant. That's absolutely brilliant. Well done on that. As I said, I've been a big follower, and you write exceptionally well. And so I think this will be very nice for children too. Thank you very much for that.
My book come out in June.
Nice. Yeah, it's coming up. And I hope you feel better ASAP, and that the nail comes out of the tire.
Well, not yet. Not yet. We want the nail to stay in the tire until I get a new tire.
Oh yeah, for sure. Definitely get the new tire. If people have questions, okay, I think I see. Here you go. Why not, Victor? If this is the same Victor from earlier, you did very well on some of the questions in the quiz. Starting from zero, what is a good route to learn Spark?
Well, of course, I'm biased. I think distributed computing for kids, if you're truly starting from zero, is a fantastic place. On the other hand, if you're maybe starting from like experienced with Python or Scala or Java or something like that, maybe familiar with pandas, Learning Spark is a great book. I co-wrote the first edition. I don't get any money from it, so I don't really care if you buy it or not. But I think Learning Spark is a solid book, and I heard a rumor that there's going to be a third edition of it coming out pretty soon as well, from our good friend Scott, who's amazing.
Yeah. So hold on. Actually, maybe we can linger here for another moment, because
Yeah,
this might be an interesting, just like flashpoint. A lot of people are coming in from like data engineering and big data and having a lot of intuition and understanding sort of like the role of Spark. And other people might not. They might come at it a little bit more from like right now Gen AI agents
yeah.
trying to build context. Can you help to bridge the paradigms a little bit? Like, at what point do people take a step back and say, this problem is a Spark problem, let me try to ingest these books and figure out how to get started?
Yeah, I mean, so fundamentally, I think uh, the classic way where people came to Spark historically, right, was like you would come either through MapReduce land, where you were like, wow, I've got this like really annoying big data job. There's got to be a better way, right? And for those people, it's not that much of a jump, right? Because it's like it's a different paradigm, but it very much solves the same problems, right? So like your intuition around like this is a MapReduce problem was a pretty good fit for like, oh yeah, this is also a Spark problem. But that's changed, right? And so now I think we've got a lot of people coming, as you said, from sort of more of an AI background or other backgrounds. So I think the intuition that I use to decide when something is a Spark problem is like, hey, is this a problem which is either really slow, right? Like, is it taking a really long time? Or is it so big that it's just not working, right? So like, is it either really slow or really, really giant? And then the other part is like, if it's really slow, the question is, can I split it up on a per record basis, right? And that's maybe
Hmm.
not perfect, right? But essentially like, hey, does it make sense to think about processing things either in like groups of records, or does it make sense to think about some other sort of thing? And if it doesn't, right, like that doesn't mean 100% it's not a Spark problem, but it's a really good sign if it's like, yeah, it makes sense to process 100 records, another 100 records, another 100 records, and then we combine them all together with some other special steps, right?
Hmm.
And if those things are looking good, then like, yeah, this is probably a Spark problem. Um, Okay, and yeah, I see the comment of like if your data is below several TBs, it's not a Spark problem, it's a DuckDB problem. I would say maybe, and this is sort of a flip side question. Like, if sure, if your data is small, you don't have to use Spark. But there's this group of problems where it's like, yeah, my input data is small, but what I'm doing is actually really, really slow, right? And like, yeah, I could solve it on a single computer, and my life would be so much simpler. The problem is, by the time it was done, I'd be fired, right? And so it's like, cool. If the job is so slow that it's like, yeah, it's gonna finish, but not in a time that's useful to me, then like that Spark can still sort of step up to the plate and win. But on the flip side, if it's running quickly and it's running locally, that's amazing. Don't use Spark, right? Like your life will be so much happier if you never have to learn this shit.
We got to keep going. Holden, thank you very much. By the way, that class of problems has been how I first was introduced to it. I saw how long it took on my computer to solve the problem I was trying to solve. And then I forecasted how long it would take to actually get the full, not just like a little demo. And it was like 150 years. And I was like, okay, that doesn't sound, I think I need to parallelize this better. And that's how it wasn't, I didn't have terabytes of data. I had maybe 100 gig maybe of data,
Yeah.
even tens of gigs, but just the
I
nature of it made it so that I just had to use something like Spark.
Yeah, I have this happen with even hundreds of megs where it's like I'm doing something super complex. It frequently happens in Gen AI space where you're like, yeah, I'm doing this really weird stuff to this record. It takes a long time.
Hmm. Absolutely.
Sorry for
Nice, Holden. Thank you very much.
troubleshooting.
Please stick around the chat. I do see that we have some questions that we didn't get.